Okay, so let me put these answers up from last night, give you a chance to look at them. And I'm pretty sure I'm probably have to do a couple of them with you, and that's okay. But here they are. I know last class really struggled with the last couple of problems, maybe not the last number 8, but 6 and 7. They struggled with just a little bit. So if that's true for you guys too, we can go over those problems. But go ahead and check those real quick. I didn't want to put these up while I was checking because there wasn't a ton of just like work that needed to be shown for these. You basically have to write the equation and then plug in a year or a day or whatever amount of time it was. So it wasn't just a ton of work to be shown here. No, because it says it depreciates. Yeah, it depreciates, so you should have subtracted the 0.17. Yeah. So 1 minus 0.17 is 0.8. Oh, you may have just had 1 minus 0.17. That's fine. I just simplified it. So if you didn't simplify it, you still got the same value. You just, yeah, no problem. Yeah, you're good. We're on the same page here. Did you watch me hit dingers yesterday out in the facility? Huh? I tell Brandon all the time I could probably hit. If he ever needed to put a wig on somebody just to get a guaranteed home run, I'd be the guy. I can kill a ball. Finally, it took me a minute. It took me a little longer than I wanted it to. But at least Madison didn't pass out from having to plank for that long. Okay, so y'all checked them? So what we need to do? Anything? Jimmy? Number 8? Okay, let's go check out 8. And Grace, I'll get whatever you are asking about in just a second. Okay, number 8 says the change in the population of fruit flies can be modeled by the equation y equals 4 times 1.45 raised to the t, where t is time in days. This can apply the appreciation or depreciation formula. So A, is the fruit fly population growing or decaying? It's definitely growing. Again, how do I know? Because the base of your exponent is greater than what? 1. If it's greater than 1, it has to be growing. Okay? Essentially, guys, what has happened for it to get to 1.45? You've taken 1 and you've added what? You've added 0.45 to it. Right? So that'll help us answer the rest of the question. What is that daily rate of growth? It was 0.45, which means it was what as a percent? 45%. And then, of course, the last question I think probably all y'all understood pretty well. What was that initial value? 4. Remember P out front? That's your initial value. So your initial amount of fruit flies was 4. Okay? So that's how we know. If that value that's your base is over 1, it's growth. If it's under 1, it's decay. Okay? Yeah, for sure. Here they are. Grace, did you kind of have your hand raised?
Yeah, number 7.
You want me to do 7? Okay. 6 and 7. I figured y'all would ask about 6 and 7. That's what we went over in the last period. So, tell me, Lily, when you're ready. Huh? You're good? Okay. So let me go back to 6 and 7 real quick, and we'll knock those out. So if you look at this particular problem, number 6, it says Alex purchases a tractor for $35,200. The value of the tractor does what? Depreciates at a rate of 7.9%. Okay, so I know what kind of formula I'm already using. Depreciation. So that formula, A equals P. What's my initial amount? 35,200 times 1 minus my rate, which how do I write it, Grace? 0.079. Remember, you move your decimal 2 to the left, and then that's raised to the t power. But this question doesn't want just normal depreciation. It wants it written monthly. So here's what I did. I did 35,200. And then I went ahead and typed into my calculator 1 minus 0.079. What did y'all get when you did 1 minus 0.079? 0.921. And like we talked about yesterday, the only thing you do differently when you're dealing with this particular type of question when they ask about monthly depreciation is you raise that base to the what? 112. And to make up for that, on the outside, you raise your exponent to the 12t power. That's how you should have answered A. Now, B wants to know, hey, what is that monthly depreciation rate to the nearest 1/10 of a percent? So here's what I do. I take just this stuff right here, and I go type it into my calculator. 0.921 raised to the 112. So I take 0.921 and I raise it to the 112, and I get 0.993. Okay, if y'all type that in the calculator, I'm sure that's what you'll get as well. Now, that's not my answer because that's just taking into consideration what that rate would be to the 1/12 power. What we want to do now is, realizing it's depreciation, it's less than 1, we're going to subtract that new value from 1, and that will let me pinpoint what the individual monthly depreciation rate will be. So 1 minus 0.993 equals 0.007. Now, is that a percent? No, that's a decimal. How do we now turn a decimal back to a percent? You move 2 to the right. See, we did it the opposite way to go percent to decimal. Now decimal to percent, 2 to the right. So it's 0.7%. That's how much it would be per month. Okay, per year, it was 7.9%. Per month, it's 0.7%. Okay? I think I may have mentioned this yesterday. I don't remember if I did it in every class. But somebody asked me, I didn't mention it until 4th period because it was asked in 4th period. They said, why can't you just take 7.9 and divide it by 12? And I'm like, that's a good question. Because if its annual percentage is 7.9%, there's 12 months, why can't I just do 7.9 divided by 12? Well, when it comes to exponents, it's just not how it works. So, therefore, you have to raise that value to the 112, and that's how you get it. Now, 7 was almost identically the opposite direction. Look, isn't this value greater than 1? Yeah, so what did I do? I took 1 and I added how much? 0.04, didn't I? So therefore, A, we're going to simply, well, I guess that's important for me to understand here in just a second. But basically, my yearly interest rate was what? My yearly. 0.04 is the decimal. So what is that as a percentage? My yearly was 4%. Now, I want to find the approximate monthly. So this actually made it a little easier on us because we simply need to write this where we've taken that value underneath and we've raised it to the what power? 112. And to make up for that, we raised that power on the outside to 12t. So really my focus becomes right here. I want to figure out what that equals. So I go to my calculator and I type in 1.04 raised to the 1/12. My goodness, I'm having a hard time writing numbers. So 1.04 raised to the 1/12 is 1.003. Now listen, because it's above 1, remember the last one was depreciation. So we subtracted the value from 1. This is appreciation, so we're actually going to subtract 1 from that value. So we're going to do 1.003 minus 1, and I'll get 0.003. Sorry, 0.003. So therefore, what is my monthly appreciation percentage? 0.3%. Remember, we moved that decimal 2 to the right, and that tells me my monthly is 0.3%. Okay? So if it's depreciation and we're trying to figure out the monthly, we subtract it from 1. If it's appreciation and we're trying to find the monthly, we subtract 1 from it. Okay? Any other questions? Y'all feel pretty good about this? Okay, now we're going to move along today to the next thing on our agenda, and that is compounded interest and continuously compounded interest. What I want to do while I'm passing this out is give y'all a chance to take a picture of this. This is the formula sheet that I gave you guys yesterday that you're going to be able to use on the test. Okay? Now, I just want you to use the formulas on the test. So you can't use it as a cheat sheet. So I will be checking it when I give you guys the test. But go ahead and take a picture of this. Or if you write real fast, you can just jot it all down on your formula sheet that I gave you yesterday. Was anybody not here yesterday? Did you get that? Okay. And your words on the top don't have to be, like if you already filled those in on the top, if your words weren't exactly the same as mine, it doesn't mean they were wrong. You don't have to erase them as long as you know what they mean. So A is that total amount, P is the principal, the initial amount, T is time, which is generally in years, not always. Generally it's in years. And then of course rate is your R. So, I'm going to give y'all a couple minutes. Go fast. Give y'all a couple more minutes to do that. And then we're going to jump into today's lesson. While y'all are writing, I'm going to say one thing about today's lesson. The first formula that we're doing, it is really, really similar to appreciation. Remember we did appreciation yesterday. It's P times 1 plus R raised to the T power. What we're doing today, compound interest, it's very, very similar to that. A compound interest is always going to be adding. Okay, we're not going to do compound interest for losing money, right? We're doing compound interest for gaining money. So it's a lot like appreciation, except for it adds one thing. One thing. And it adds this one thing in 2 places. So if you understand that, it actually makes today quite easy. So, are y'all close? I'll give you about another minute. And then we're going to jump into compound interest. We're doing 2 equations today. Compound interest, and then this other one called continuously compounded interest. So it sounds like they'd be very similar to each other, but they're actually not. Compound interest and continuously compounded interest look very different. Okay. All right. So if you did not get all that written down, maybe just take a quick pic of it, or grab somebody's paper who did get it all written. I probably won't have to put this back up again though, but please keep that formula sheet close to you. All right, here we go. So today, we're going to talk about compound interest. And I already told you that it's very similar to appreciation, but it adds one thing, and it adds this one thing in two places. So in these two places, this particular value will be identical, same. And that is the number of times something gets compounded per year. You see, with compound interest, when you read these word problems, it will specifically say to you, it's compounded blank. And these are the different words they might say. They might say it's compounded annually. Well, compounded annually means how often? One time. Compounded annually is appreciation. Okay? It's just the same formula as appreciation. But when we start adding, like, don't you want your money to get compounded more often? For sure. We want our money to be compounded more often. So here are the different terms that we're going to use. Compounded semi-annually. How often do you think that happens? If it says semi-annually, it means 2 times per year. What do you think it means if it says quarterly? Yeah, 4 times. Y'all know quarters. 4 times per year. How about monthly? 12. 12 months in a year. Weekly? Nope. 52. There's 52 weeks in a year. And then, how about daily? 365. 365. So, these are the words that it adds. So let me show you guys what I was saying a second ago. Look at this formula compared to appreciation. Appreciation was P times 1 plus R raised to the T. Notice how similar it is? It adds one thing and it adds it in 2 locations. Inside our parentheses, you divide the R by N. But then on the outside, you multiply your T by that same value of N. And N, guys, is the number of times it's compounded per year. So if they said semi-annually, what am I putting in N spot? 2. If they said quarterly, what am I putting in N spot? 4. If they tell me monthly, what am I putting in N spot? You get the point? So see how similar it is to appreciation? It's almost the same formula. The only difference, of course, is that value of N. Y'all with me? Okay, now let's work out a couple of problems. Example 1. Wendy deposits $550 into a savings account. The account pays an interest rate of 4.5% compounded quarterly. See, they're going to tell you compounded blank. That's how we know it's compound interest. You got me? It's not going to be rocket science. You're going to have to read a problem and have to decipher on your own whether it's compound interest or appreciation. It's literally going to say it. Just like this said, compounded quarterly. So here's my formula. Y'all ready? It says write a function that gives the amount of money in dollars, W of T, in Wendy's account T years after the initial deposit. So here we go. Ready? We always start with P. What's the principal amount here, guys? $550 times 1 plus R over N. Let's start with R. That's our rate, guys. 4.5%. How do I write that? 0.045. Please don't forget to make that a decimal. Move it 2 to the left. Or divide it by 100. 4.5 divided by 100. Now, here's the new thing. It's divided by N, the number of times it's compounded per year. What word did they use? So what do we put in N spot? 4. And that's raised to the N. That's another 4. t power. So what I like to do is I like to go to my calculator to simplify this equation, and I'm going to go type in 1 plus, are y'all with me? Everybody do this. Type in 1 plus alpha y equals number 1, 0.045 up top over 4 in the bottom, and tell me what you get. Okay, I'm glad you said that. He said 1.01. Now listen, does this decimal repeat? Does it terminate? It terminates. See how it's only 5 decimals? Your calculator does way more than that. This is a terminating decimal. Here's the point I'm making. When it comes to money, do you think that every decimal we can add is important? So since this is a terminating decimal, let's write the whole thing. 1.01125. Only round when it has to do with money if you have to. Because you want as much of that as you can. Think about it. If you rounded to 1.01, you're missing out on 0.00125. And when it comes to compounded money, you want every decimal. Do you want the bank to do that to you? So let's not round if we don't have to, okay? So there's my equation. Now what's the last question asked? Find the amount after 10 years. So what are we going to do? We're going to go type this in, but we're going to replace t with what? What's 4 times 10? So I'm going to type in 550, open parenthesis, 1.01125, raised to the, and you can either do 4 times 10, or you can go ahead and do 40. Either do 4 times 10 up in the exponent spot or change it to 40. But if you do that correctly, how much money will be left in the account after 10 years? $860, and we would hope they would round to 41 cents. But do you think a bank would give you that 1 cent? Nope. Banks won't round up, unfortunately. Yeah. They're not, in their mind, banks are not going to lose 0.003 cents on you. So they're going to take that from you. And they would not round to 41. They would just leave it at 40. Unfortunately. Sorry. That's just how banks roll. Okay? So do you get this? So let's do another one. A couple makes an investment of $1,800 into an account that earns 8% compounded what? Monthly. How much money will they have in 15 years? So do they ask us to write the formula here? No, they just ask us to solve it, don't they? So I'm going to type this whole thing. What I'm about to write on my paper, I'm just going to type in my calculator. Ready? I'm going to do P. What's principal? 1,800 times 1 plus, guys, how do I do 8%? 0.08 over N. What's the number of times it's compounded every year? 12. And that's raised to the 12 times 15 power. So I'm literally going to go type that into my calculator just like that. Ready? 1,800, open parenthesis, 1 plus alpha y equals number 1, 0.08 over 12, close parenthesis, raised to the 12 times 15 power. And if you do that correctly, you will have how much money after 15 years? $5,952, and we hope 46 cents. But more than likely, the bank will give us 45 cents. Even though rounding up is the way it's not supposed to go, right? So, do y'all understand this? Okay, now, that is called compound interest. Go back to the top right of this paper. Now, if we just kept compounding things more and more, see, look, Compounded semi-annually means twice. Quarterly means 4 times. Monthly means 12. Weekly means 52. Daily means 365. Hourly would be 87.60. Every minute would be 525,600. Guys, do y'all notice as we compound these things more often, y'all notice what the number is moving towards? Does that number look familiar to you? Anybody? E. This is what I was saying about E. Some things happen so often in nature. As we compound something more and more often, or like, for example, how bacteria grows, where it's not like, hey, bacteria is only growing once every month. It's constantly growing. You understand? Because that kind of stuff happens in nature so often, they call that continuously compounded when it comes to compounded interest. They call it continuously compounded. And they gave it its own formula. And that formula is this. A equals P times E to the RT power. PERT, right? P times E to the RT. That is the formula for what we call continuously compounded. So guys, when y'all are reading a question that wants you to do continuously compounded, you know what it has to tell you? It's continuously compounded. It will have to use those very words. Okay? So you only use this formula if the problem says it's what? Continuously compounded. So for example, go to number E, or 3. Man, brain damage. Sarah deposits $2,000 into an account that pays 2.7% interest compounded continuously. What formula do I use? Continuously compounded. P times E to the RT. So here's my formula. It says A, write a function S of T. Okay, so S of T equals P. What's principal amount? 2,000. Guys, do we plug something into E's spot? No, it's a mathematical constant, E. To the R, how do I write 2.7%? 0.027 T. That's my equation. 2,000 times E raised to the 0.027 T. PE to the RT. That's continuously compounded. That's the equation. Now what do they want me to do in B? Solve it for how many years? So go type in your calculator, 2,000 times E to the 0.027 times 30. So remember where to find E? A couple of places, right? Y'all tell me, where do I find E? Second division or second ln. I don't care which one you use. Both work just fine here. So which one did y'all use? Second divide or second ln? Second divide. That throws my E in there. But then I'm going to raise it to the 0.027 times 30. And I'm going to push equals. And it's going to tell me I have how much money left over. $4,495.82. And that is how you use continuously compounded formula. Pretty easy, right? So, very different formula than the compounded interest. Now, there's one more type of question, and 3 of these 4 questions are very simple. Okay? 2 of the 3 are very simple. Let me explain. The initial deposit. Guys, where do I find the initial deposit when it's compound interest? Right up front. So what's this value? 200. Pretty easy question, right? What about the next one? What's the initial deposit on B? 1,000. How about the initial deposit on C? 400. Right up front, right? And what's the initial deposit on D? So that's pretty easy, isn't it? Here's another pretty easy one. How many times per year is interest compounded on that first problem? Remember, when it's compound interest, which this definitely is, it says it right there. It's 4, right? It's 4. So 4, or you could have put what? Very good, quarterly. I would have taken either one of those. How about B? What's it? 12, or monthly. Okay, don't let the next one fool you. It's a different formula, isn't it? Isn't that PE to the RT? So if that's PE to the RT, how often is it compounded? Continuously. Very good. And the last one might trick you some too. What is T being multiplied by? It's being multiplied by 1. So how often is this one compounded? Annually. 1 time. Okay. And now the last problem, the last one's a little harder. It's a little harder. I don't want to say it's a lot harder. It's a little harder. You see, the last one you have to decipher based on right here. On these 2 problems. Actually, these 3 problems. This one right here on C, where do you find the interest rate on that one? When it's PE to the RT. Don't you find it right here? That one's actually pretty easy. That's 0.06, which is what, Ellis? 6%. That one was easy. Now let's do the others. They're a little harder. Now, go back to compound interest. Please tell me the equation for just this portion of that problem. It's 1 plus R over N. And do we know N here? Yeah, we do. What did we just say N was? The number of times it's compounded per year. It's the same as this number right here, remember? So we do know N. So here's the deal. That's how we come up with that value, don't we? So can't we take that equation and set it equal to 1.0125? And then can't I just solve it? How do I solve for R? What's the first thing I need to move? I need to subtract that 1, don't I? So R divided by 4 will equal, what is 1.0125 minus 1? 0.0125. And guys, what's the last thing I do to solve for R? So take your calculator and multiply 0.0125 by 4. What do you get? .05. So guys, what's my rate? 5%. Y'all get that? Okay, look at the next one. How did we come up with this value? What's my equation? 1 plus R over N. What's N on this problem? Very good. And that equals the 1.0025. So how do I solve this one first? Same thing, right? I subtract 1. So R divided by 12 will equal 0.0025. And what's my last step? I'm going to multiply by 12. What's 0.0025 times 12? 0.03. So guys, what's that as a rate? 3%. Y'all understand this? It's not as hard as you might have thought at the beginning, is it? To find those rates? You just use the formula. And if we go to the last one, D, remember how we found this? 1 plus R over N. Guys, what did we say N is next to that T? It's 1. Which is, doesn't that just mean it's 1 plus R? Huh? So don't I have to subtract 1 and R will equal 0.025? That's easy. Remember that when it's done annually, it's just like appreciation. So what's that as a percentage? 2.5%. Okay? So what do you think? Y'all feel pretty good about compound interest? And continuously compounded interest? Yes, no, maybe? A little bit? So your homework on this page that I'm giving you now is the first 8 problems. 1 through 8. 1 through 8. That's your homework. Yes, sir. 1 through 8. Everybody hear me? 1 through 8 is your homework for tonight. Should be able to knock those out. Any questions?